Our notes tonight are on igneous rocks. What are igneous rocks? You're probably already aware that igneous rocks are made from cooled lava, which is molten material above the ground, and magma, which is molten material below the ground. Now, classifications of rocks are always based on three things. Texture, which is the grain, and if you'll remember, the grain comes from the pieces that make up the rock, the origin, where that rock forms, and the mineral composition. And for igneous rocks, we are going to be talking about minerals because igneous rocks are made from a combination of minerals. So we must really talk about grain size when we're talking about texture, and we do have some special names for grain sizes. And the first one that we're going to talk about here is coarse grained. And that means when the grain of the rock, remember that's the pieces, and for an igneous rock, those are mineral pieces. When that cooled slowly. Now if you think about it, when it's cooling slowly, it's cooling over a long period of time, the longer minerals have to cool, the larger the crystal gets, the larger the piece of mineral gets. And so then we know that if it's cooling slowly, where do you think it would cool? Above ground or below ground? Would it cool from magma or lava? And if it's cooling slowly, then it's cooling from magma, which is, of course, below ground. Now, this is a piece of granite here, and granite you actually can see the pieces in the granite. You can see all these little black pieces here. You can see white pieces. You can see kind of a beigeish piece, some gray pieces. And each one of these grains, these pieces that make up the rock, is a different mineral. Now, a fine grain rock means small grains. That means that it cooled fast. So think about that. It cooled over a short period of time, so the grains don't really have time to get big. And so what did that form from? That formed from lava above the ground, and it can cool quickly. This sample here is a piece of basalt, and you can't really see the individual pieces of grain in that basalt. Now, origin deals with where the rock formed. And we have two basic classifications here, extrusive and intrusive. Now, in an extrusive rock, I like to think of using the first three letters of each of these words to help us remember. Extrusive means that it formed above ground. So that means that the rock material, the molten material, exited. It came out and flowed on the surface, so it cooled quickly. So it has small grains. Sometimes it cools so fast it has no grains. Now, intrusive here, we have INT, intrusive. It cooled inside or underground, and it cooled slowly. Because if you look at our picture here, you can see that this magma is trapped, and so the heat is contained. It's like putting hot chocolate in a cup with a lid on it. It's going to stay warmer longer. So this allows large grains to form, large crystals to form with our minerals. So we have intrusive igneous rocks and extrusive igneous rocks. So let's look kind of at another example of this. And you can fill this out on your note sheet for the example part. So our first example up here is basalt. And you can see over here in our picture, basalt forms from lava that has cooled fast, and so it has small grain, fine grain. Our coarse grain rock is granite, and you can see down here this magma. We've got magma here, it's still liquid, starting to solidify here, and down here in this bottom picture we see now we have rock. This has completely cooled, solidified, and we have intrusive igneous rock that's coarse grain. It took a long time for this to cool off, so it has a large grain. And so what is this going to form from? You got it, magma. Now we're going to look at the next classification and two more words that deal with the mineral composition. Now the mineral composition of igneous rocks basically depends on how much silica is in that magma or lava when it solidifies. If it's a low silica content, it's going to be dark or mafic. And I have a little saying for this: the mighty mafics are dark. And if we look at our example here, we see gabbro down here, and gabbro is a pretty dark rock. They're not always black, but they're dark. High silica content means it's light colored and it's felsic. So silica is a light colored element, and if there's a lot of it there, then you're going to have a light colored rock. And I think of this as the fair felsics are light. Fair felsics. And you can see in our picture down here, we have a very high silica content felsic igneous rock because it is just about white in color. Now, how can we put all this information together? So we have the words that we need to learn and understand: coarse grain, fine grain. So in this chart, if it has small or no grain, we're going to read down the column like this. If it has coarse grain or big crystals, we're going to read down the column like this. So granite and gabbro are both coarse-grained rocks. Fine-grained rocks are rhyolite and basalt. Now, each of coarse grain and fine grain can have a lot of silica or not in it. So remember, our fair felsics have a lot of silica, so they're going to be light-colored. And we'll read across on the row now here: granite and rhyolite are felsic, and our mafic rocks examples are gabbro and basalt. So we'll read across in this direction. So we have four rocks of four different classifications. We have rhyolite right here, which is a fine grain felsic rock. We have basalt right here, which is a fine grain mafic rock. We have granite, which is coarse grained and felsic, and gabbro, which is coarse grain and mafic. So that kind of concludes our description of rocks based on their grain size and composition. And that's the end of our notes for tonight. Bring your completed notes to class tomorrow.